So let's get to the panel discussion. You have all the bios of the people, so I'm not going to introduce them. What I want to do is I just introduce this because I put this out in the morning and some people asked me some question. I did not have any Q&A time for my talk. So I thought I'd put this question out to panelists as a starting point because as we go to Wi-Fi 7, maybe I want some reflection on whether do they see something similar, different, or maybe part similar, etc. So whoever wants to start. Nadeem, would you like to start?
So yesterday I was speaking with somebody from ISP industry who was deploying Wi-Fi 6 in homes to complement their 5G FWA. So I asked them, what made you move from Wi-Fi 5 to Wi-Fi 6? So they said the AP has TR369, so I can manage the device better. Backhaul is better. That's the reason. So I think the bottom line is that some of these features we get very excited about. When we came to Wi-Fi 6, we got very excited about OFDMA. Right? It will solve all the problems of channel access and so on. But sadly, it didn't work out that way. And now I think everybody is betting on MLO as the new killer feature in Wi-Fi 7. But as you have said, I think we need to see, is it really going to meet the promise or not? So I think there is healthy skepticism in the user community. By user, I mean people who buy Wi-Fi and deploy Wi-Fi in terms of, what do I really get out of this upgrade? And the other reason is that it's coming very close to Wi-Fi 6, right? It's not like 2 years since Wi-Fi 6 became mainstream. So people are still wondering, why do I need something new when I just got something 2 years back? So there is a challenge for the industry to sell this to the end customers and also to demonstrate that this is beyond 4K QAM and 320 megahertz. There is some real meaning or real performance improvement that a lay network or a lay user can get out of this. So that's really the challenge for us in the industry to figure out how to kind of remove the skepticism among the customers on the utility of Wi-Fi 7 and it should not just become yet another standard.
Anybody else? Rajesh? Any comments on this point or anything related to that? I mean, I thought it will be more provocative. Somebody will disagree with me and say, you don't see what's good in 6 and 7. Maybe Prasanna. Yeah. No, Rajesh, you can start. Yeah.
I would like him to disagree first.
Yeah.
Please go ahead. You want me? I wouldn't disagree because I am a hardware guy. So I think every feature that we didn't put our heart and soul into designing and productizing, believe it's useful. So I would disagree with you there. But yeah, I think maybe you will have some points. Right?
Rajesh, maybe you can also share and then we can go to Rama.
The only point I want to make is we are making incremental changes that may not show us the advantages in the current generation. But as we have seen with any of these old technologies, after a couple of generations, you start utilizing them better. The backward compatibility issues take a back seat a little bit at that time, and that's when you start seeing the advantage of a feature introduced today. So anything you do today might be useful after 8 years.
So MLO will be useful in 2030. Fair enough? Just like
except in backhaul, perhaps.
Yeah, sure. Rama?
I can probably argue both ways. Okay, but let me first agree with it. 11N, I think, was a dream come true. I don't know. If I look back, I think everything worked almost perfectly. I mean, we introduced MIMO, and it just worked.
Aggregation also.
Yes, yeah. Aggregation worked. Okay. Whereas, I think, if you come to the other side, I think the changes have become incremental in the sense it is taking multiple generations to kind of stabilize or mature the new features. Again, if you want to go back and say, okay, are we getting lower latency? Now, that's a very loaded statement. There are so many elements in the network. We don't even measure latency properly in all the elements. So I think there is still a lot of work to be done in this, and probably the marketing is that it is going to provide lower latency at least for the time being. So
Yep.
it's still not there.
Sudarshan, any thoughts?
Yeah, I believe all the new features are useful, but we need to know when to apply what.
So I think everybody seems to think that, I mean, except maybe Prasanna says, I worked hard, so it better be useful. So otherwise people say, maybe wait till 2030, 35, etc. Okay, so maybe just to go to the next question. I think already Nadeem raised the point about, some features, etc. So anybody wants to take a hit, and if you're going to look at Wi-Fi 7 and take a guess on which feature might be standout, whether it's in the near term or maybe slightly in the longer term, what would your bet be on? Any of you can start, maybe Rama?
Yeah, okay, so MLO, I think, is the step in the right direction. I'm not able to guess whether it is going to work immediately. But I think it's a step in the right direction. Number one, we are able to deal with multiple channels. It is needed at some point of time, so maybe it's better we start now. How will we sort out this whole thing about different types of MLO, the cost, complexity? I think it will get sorted out in some time. So looking back, maybe 10 years afterwards, maybe MLO would have been a breakthrough, at least as far as Wi-Fi is concerned.
Yeah, I think I would second that. MLO, and in particular, I think in MLO, EMLSR, I think is something that is, I think, very immediately going to be useful for a lot of client chipsets, right? And also from the point of view an AP, the advantage is kind of very clearly there in the sense that you are like backing off on multiple, you have twice the probability of getting hold of a channel using EMLSR. So I think that gain, even though there is a lot of other blocks in the, in the software stack, I think that fundamental gain is going to be there with EMLSR, and also, kind of giving that benefit to a lot of low-cost clients who don't need to build that kind of complex radio structure and yet get the benefits of MLO. So I think, MLO, and in particular EMLSR, would be the first, technologies that would really get, proliferated.
So just to put yours and Rajesh's comment, maybe sometime in the future, majority of clients with EMLSR and MLO AP, you would see a substantial benefit in, let's say, latency, performance, etc.
Yes, though it is hard to quantify, but I think there would definitely be at a given cost, right?
Okay.
At a given cost, point. Right?
Any of you have any comments before I open up the floor for questions? Sudarshan.
Actually, for MLO, I agree with them. I also see probably EMLSR being the earliest being adopted. Maybe SCR, from marketing point of view, we can call it full duplex system in Wi-Fi. But I doubt if SCR will be used in like mobile devices, maybe laptops, possible. And then preamble functioning, I think it kind of gives us the flexibility to allocate or reallocate the number of RUs needed. And definitely, I think there is scope for DFS and AFC. How to avoid those use interference channels.
Any other part? Otherwise, if you have questions, please put up your hand. Maybe Nadeem will add.
I think one sort of side benefit I see of MLO, when we have all these crude band steering algorithms in APs, hopefully with MLO, we don't need to rely on those clients, don't need to switch bands. They can seamlessly access any band if they're capable. And second is, I think, beyond the enterprise Wi-Fi and on the Wi-Fi side, also some use cases it is enabling in the point-to-multipoint radios, which are based on the Wi-Fi chipsets, where we need aggregation of carriers. So rather than building different radios with different bandwidths, here we should be able to leverage this also to create fatter pipes for point-to-point and point-to-multipoint unlicensed radios.
Sure. So I think open the floor. Please get the mic to somebody. Where is our mic runners? Yes, Sai's question. Use the mic, please.
Some of these seem very perfect for backhaul compared to front haul, right? MLO as an example, and 4K QAM between static links if you have a line of sight. So, even today for mesh topologies, which of these do you think will work for backhaul?
Rajesh, you had something about backhaul. Why don't you maybe take that comment? Yeah.
So This seems to be the previous question still, and we have to split these in terms of access versus mobile. So from access perspective, STR does work. You can have STR in the backhaul. On the mobile, anything more than EMLSR is too costly, prohibitively complex, not worth deploying so many antennas, etc. Even the antennas for EMLSR, the front end for it makes it quite less useful. So as a mobile device manufacturer, I would like to use just MLSR, single radio, trying to juggle between, not even E, forget STR. So from the access side, yes, you can see any of these features working out great depending upon the specific use case. 4K QAM, definitely not in access, even in line of sight. You need special antennas, still it's not going to work out. But yes, it may work out for you in your VR headset kind of scenario, AR, VR, specific niche use cases. Puncturing, static puncturing would be useful quite a lot in the initial deployments. That would see one of the best use cases out of all these features from the mobile end as well as seeing the advantages. So that would be my split of how the access versus mobility is going to shape up.
So just to maybe recap, so STR, MLMR backhaul and EMLSR with clients. That would be probably your sort of pick of what might happen. Oh, but I'm putting E before that, but
no MLMR.
Yeah.
No
MLMR, so
anyway.
EMLSR, MLS. Okay. Anybody else wants to comment on that? Otherwise, we can move to the next question. If there is a question, please put up your hand. Mike will come to you.
Yeah. Hello.
Go ahead,
Yeah,
please.
I just want to answer this question. Actually, we have seen personally the improvements for this MLO. So we have also tested and we see that there are improvements for this MLO, definitely.
So is there a question?
No, it's not a question, it's just a
Okay,
statement.
thanks.
Yeah,
Yeah.
it's
Thanks.
as long as we have more clients on the field, right, definitely it's useful.
Okay, thank you. Vinod.
So in a typical US or an European home or Indian home, so is there a throughput need that really necessitates MLO? Is there a high throughput need excluding VR or AR? If that part is excluded, is there because if MLO's primary benefit is link aggregation and reduced latency, is that even needed for residential purposes?
So anybody of you, yeah, please.
Latency perspective, I think so. Yes. Not necessarily from throughput perspective.
I think if you look at the typical backhaul bandwidth in ISP networks, even if people who are selling, gigabit fiber, 30 Mbps to 10 Mbps is what the typical range you would see. So from a bandwidth perspective, probably not very useful, but as Sudarshan said, reducing the access latency is where really the value will come from.
One comment I see is that the MLO will be more useful from a latency perspective than a throughput perspective. Is that a correct?
This kind of scenarios.
Okay.
Typically, the real fans of real-time gaming applications, they use more of Ethernet than Wi-Fi. The ones who use who need to crunch a lot of bandwidth till now. Will MLO try to change that?
You are the use case.
Anybody who has gaming, Rama, you want to answer, or anybody else has gaming? If you have comments, please add.
Yeah, if the question is, if I'm actually a gamer, will I use Wi-Fi? Probably no. I think, okay. Yes, so I would surely trust the wide network today than the MLO. Okay, but as I said, it may mature in some time, so I have some hope
Rajesh?
in that direction.
No, latency is nowhere close to wired, so I don't think you should switch over. You lose the game.
So play games with wires. Yes. 1 minute. Whoever has the mic, please get her a mic.
Dr. Srikanth.
Nihar, yeah, ask.
So my question is, okay, I'll come to these 2 points where I have seen some MLO benefits.
Please use the mic close to
MLO has significant benefits, but the use case define how you are going to use the MLMR or EMLSR. There are significant scenarios, different scenarios. Based on different scenarios, MLMR will work, and which will, in other scenarios, MLSR will work. So my question about 4K QAM, because I have seen many challenges of connecting on 4K QAM. when it is coming to 320 megahertz and 4K QAM connection, MCS 12 and 13, your client should be in a very good RSSI and different airtime and all these things comes into picture. So do you look 4K QAM is a bit challenging in the real-time scenarios?
So quick, I think Rajesh already mentioned 4K QAM is useless, but maybe you can reiterate. Yes.
You can't use 4K QAM unless you are within a couple of meters. It could be used as a HDMI replacement if you want to build on Wi-Fi, if you must build on Wi-Fi. Like you got those VR headsets that live on your pocket or somewhere near your hip and they have to transmit the signal to your eyes. You want to avoid the card for it, perhaps you can go ahead for such niche applications. Otherwise, 4K QAM, even at the straight line distance with nobody standing in between the two of us, it's not going to work.
So are you working on one such device because knowing whom your customers are?
No,
No.
I'm here on personal basis.
Rama, did you want to add anything on 4K QAM? Nothing.
No, I think there's a joke that people were saying that the client has to sit on the AP without the H for the 4K QAM to work.
Yeah, go ahead, please.
Yeah, I have a question related to MLO. So with respect to interoperability, what will be the impact? Did you get my question? I mean, what will be the impact over the interoperability when we are using MLO?
Is the interoperability related to, I don't know,
So
link reconfiguration, or is it?
Interoperability in the sense with the commercial devices. For example, there are multiple devices, Amazon Fire TV, printers are using, and then there are, legacy devices are connected. Securities are different, because what I have observed, when you're using security especially, so when you're using mixed mode, WPA2 and WPA3, so I have observed there is a interoperability issues. Sometime the WPA2 device will get connect, sometime it won't get connect. So when we are using MLO, it is a very complexity, because there will be a multiple features. One link will be using, another link will be using another device to be connected, like printer. For example, one link is in 2G, and it has connected with the mobile. And second link is generated in 5G, which is connected with the printer. So what the interoperability process?
So I will take it as two parts. First is that by definition, the Wi-Fi protocol is backward compatible. So all older devices will work.
Yeah.
Now, whether this is all tested, I do not know, but once the certification is complete, this would work. I don't see a new problem being introduced by simple MLO connection. If you ask me, I think yesterday we discussed reconfiguration, etc. is still not completely mature, but there's no new interoperability problem that MLO would create.
Okay.
That's my opinion.
Thanks.
Anybody else wants to add anything on that? You have to get a mic.
I'll just add that you must definitely have a legacy BSS if you want interoperability. There are still printers out there that expect you to have a 11B mode, etc. And you cannot use WPA2, which publishes multiple AKMs, multiple cipher suites. They cannot even parse those sort of things. So please go with caution. Do set up extra BSS, which do have the legacy BSS alone. If possible, not with the same password.
Jatin.
Yeah. So I'll go back to the first question that you had put up on this board, is that, see, we have been putting out features, since 11G, especially after 11G, right? And AC wave 1, wave 2, then AX, then Wi-Fi 6E. Newer features are being added. Now, we know that some of these features have never worked in the field and are likely never going to work. Like the MIMO in 11L, I don't think it even works today, right? So my question really is, we are putting out all of these features. Some of them don't work. So why don't we work towards making these features work before adding new and new features, right? Because, like OFDM, you don't see that happen because scheduling is a problem today. Client grouping is a problem. Then we came with OFDMA. Then uplink OFDMA is still an issue. So why do you think that people don't work to make things better of what they're, because we keep on putting newer things, but we don't.
Sure. So just to summarize, he's saying that we should not have done MLO, improved OFDMA and MU MIMO. Any comments? Quick. So no, nobody disagrees. Any comments? Prasanna, you have any comments? You worked so hard on MLO. He's saying we should have worked on improving OFDMA and MU MIMO. So Jatin, everybody agrees with you. Okay. So I think part of this, so we'll just take a pause from the audience questions. I think part of this is already answered. I think Rajesh has commented. So just ask for some comments. In the presence of legacy, what can we realistically expect? Is there any thoughts on that? I mean, of course, greenfield Wi-Fi 7 is a myth. So we are always having legacy. So do we see all those latency improvements potentially possible and other evaluations in the presence of legacy? Any thoughts on that? Anybody wants to share anything which you might have done or come across or at least have an opinion about? Are we realistically going to see, at what percentage of Wi-Fi 7 will we see some realistic benefits? Take a guess. Prasanna, what percentage of Wi-Fi 7 will we see benefit? 50%, 60%? Any guess from anybody? Rama?
Yeah, it should be more than 50%.
More than 50%. So more than 50%, what time frame are we expecting to see? Any idea?
Yeah, I do not know, but I did attend a Wi-Fi Alliance conference, and in the survey, it is very, very clear that none of these guys are going to even move to even Wi-Fi 6 in the near future. And apparently, about 80% of the devices are AC or lower.
Wi-Fi 5 or 4?
Yes.
Okay.
In the wider market, not what they are selling today. And obviously, they have, instead of saying backward compatibility, they also have a forward compatibility issues. Like they don't handle extensions and stuff like that. They will crash or they would not work. And so this kind of prohibits introduction of new features. I know if you, most of the people in this audience may be aware that WPA3 transition mode in Wi-Fi 7 is an issue. It's being debated for the last 6 months. So as I said, 50% or more.
Okay. Anybody else wants to comment for legacy?
Clients kind of seem to move a bit earlier, right? But from my experience, for instance, the Samsungs and the mobile phone makers of the world seem to jump on to the newer Wi-Fi technologies first. For instance, at least I think they already have some launches of Wi-Fi 7 on at least their premier phones. So if you look at it as at a cadence of like 3 or 4 years, when then they start, introducing it into their, lower end phones, maybe around 4 or 5 years, we might be seeing and assuming that people do refresh their mobiles, right, once in 4 years, on average, once in 4 or 5 years. We might start seeing a sizable number of Wi-Fi 7 capable devices, at least in people's hands. The bigger problem is APs, of course, right, because people generally, it takes a lot to move from
reinvest in
a new AP.
Okay.
In my opinion.
So the quick added question might be just to see, why do we then jump standards every 4 or 5 years when you know that one standard is actually going to take next 4 or 5 years to actually probably make an impact? Any thoughts on that from anybody? Or is it just business which drives that?
I think if you look at the 3GPP approach, right, LTE started with release 19.
Release 8.
Release 8, right?
Yeah.
And went on till release 14 almost. So 7 releases all devoted to LTE, and this was spread over 10, 12 years. Similarly, we look at 5G, starting with release 15, going all the way up to, so there is a longer sort of life of the 3GPP generations. Compared to that, I see that Wi-Fi is jumping too fast, maybe in order to catch up with the 3GPP releases, and it's demand of the market, so IEEE has to go in that direction. But as a consumer, then it's kind of confusing, right? You're selling me some shiny new thing today, and then 1 year later you'll say, okay, buy UHR or Wi-Fi 8.
And the advantage of the shiny new thing comes only
after 5 years,
yes,
right?
Okay.
So there is a challenge here, but I think we have to keep pace with other competition. But at the same time, I think coming back to the question that Jatin asked, it's not an either or choice. It's not like I should only do improvement on OFDMA and not do anything else. I think there should be a balance between making sure that whatever was defined in the previous spec gets improved in the new spec while we are adding more features. That healthy balance is required. It's not just a binary choice, do this or that.
Okay. So now comes, like you already told, my Wi-Fi 7 is not going to be useful till 2029 or whatever time frame. So is that extra complexity cost commensurate with benefits whenever I get them? Is it worth potentially looking at Wi-Fi 7? Or is it an over-costly exercise? Already you have said that STR, MLMR clients probably are not a big hit. So in that sense, we've already kind of pivoted towards possibly an eMLSR or with or without the E, right? So towards the client side. So overall, do you think the whole basket of features are commensurate with the benefits whenever it happens? Any comments on that?
Maybe I would like to answer for the 4K QAM and maybe even 320 megahertz in Wi-Fi 7. I think definitely 4K and 320 megahertz, they pose a problem in RF design. So let's say if someone designs for 4K QAM, definitely it's going to improve the 1K QAM and so MCS 11 and MCS 9.
So you're going to better the previous QAMs.
Yeah.
Okay.
So that's one way I see it.
So introduce MCS 12, 13 so that 10, 11 can improve. Yeah. Okay, good. So MCS 10, 11 was not doing good previously when you sold us.
It could be better now.
Okay. Any other thoughts? I mean, is it worth the yeah. Check or pass the Sudarshan's mic.
So I think I'll just deal with the first part of the question. What might be the extra complexity, right? So from someone who's like, built these solutions, I can kind of talk about, I mean, as far as complexity goes, I've kind of been involved in Wi-Fi development from, I think I started around 11 AC, right? So from compared to whatever we've done so far, as far as complexity goes in Wi-Fi 7, it was significantly far more complex. I mean, looking at it from all the parts of design, right? VLSI design, be it architecture, especially validation and productization, right? Given that we're already kind of dealing with the extremely large, complex set of control cases to validate, and when you kind of add one more link or two more links to it, right? And the space of validation just grows exponentially. So it was probably one of the most challenging productization efforts. And will it be commensurate to the benefits? Well, I think it has the potential to be, is what I would say, because at a very fundamental level, this is like carrier aggregation, which worked so well for, in the mobile world. And it's probably breaking away from what Wi-Fi has so far done, which is mainly look at increasing throughput, right? The earlier versions of the standards have mainly dealt with, each standard is better. But this is kind of I would say a new direction, right, okay, to the standards in Wi-Fi 7. So whether it would be commensurate I think depends on a lot of other factors. But I think it has the potential to be.
How would you compare the effort from Wi-Fi 5 to 6 versus 6 to 7? Because you worked on that.
Yeah, it is like, I would say that it's not 2x or 3x. I would say 10x, right? Okay. That's how challenging it was.
So because you charge 10x or?
You still get paid the same. So okay. Yeah, because you had all these, so many different configurations of MLO. And and things going across chips, inside chips. Yeah.
So it's a pretty complex, at least
very
on the
complex.
AP side, you've
very
seen
complex,
that.
Very
and the
complex.
client side also with eMLSR has its own complexity.
The client is okay. I would say, I wouldn't say the client is that complex, but the AP definitely, when you are looking at a Wi-Fi 7 AP with all its bells and whistles,
it's a pretty complex piece.
It's a very complex piece of hardware compared to the earlier generations.
Anybody wants to add anything? I mean, Sudarshan said it improved our QAM performance of previous generation. And Prasanna has like MLO is really a complex beast at the AP side. Anybody else? So maybe I'll open up the floor for a couple of more questions. Any thoughts or questions that you want to ask the panel about these things? Some new faces would be nice always. Anybody has any questions? Rajesh, anything want to add on from your view of how the MLO complexity? Do you see that in a similar vein as Prasanna, or?
The access has indeed become quite complex from the data perspective. The amount of data that is flowing through a single link and can potentially be distributed, that actually means that you still have to carry it on a single link if required. So even behind Wi-Fi, it has become complex. Now within Wi-Fi, the complexity comes from all these features, but I believe that STR does have a huge role to play in the access side. Okay. The access point is always STR. It has to be available all the time. And 320 megahertz, again, is going to be quite useful in backhaul. and puncturing are going to be useful. So the complexity is indeed worth it, at least at the access side. From the client side, yes, some kind of single radio, multi-link, MLSR thing that we talked about, that's what is going to stand out if you properly implement it, even without the E.
And what about the scheduling complexity? I mean, both of you talked about bare bones implementation, but the scheduling is proprietary. So do you think there is scope for, in fact, that would have been my next question. So do you think that there is scope for differentiation in terms of the MLO performance amongst different products? Do you see that scope? Any of you can answer, but just...
Yeah, I think the point is because the MLO, whatever is there in the standard, as far as MLO goes, is just very bare bones and kind of whatever is basically required to ensure that these devices don't stomp over each other on the medium or you don't have collisions and all that stuff. And a lot of other details, right? Going from the scheduling algorithm that you mentioned, as well as, you know, how dynamically you do this channel aggregation, right? At what point you do it? Do you do it like close to the host layer? Or do you do it right in time over the medium, right? That makes a, you know, huge, will make a huge difference to how much latency benefit that you actually get from it. Then adding to that, there is also a lot of this is going to be in the software stack, which is again left to each vendor, right? How he optimizes it, right? And what kind of QoS, quality of service, how does he decide to, you know, make best use of whatever the MLO hardware gives to and kind of provision it to, you know, certain services which need that quality, right? So that way, I think that there is a lot of stuff which can be proprietary, right? And yeah, there is a lot of scope for differentiation.
So to Nadeem and Rama, then your evaluation, maybe Nadeem, you can say.
I have a question also. I actually have a question for Prasanna and Rajesh. That scheduling, at least till now, has primarily been like a WMM-based, some priority-based scheduling, right? But with MLO, now that you have, you know, it's advantages for certain type of applications only. So do you see more application-aware scheduling coming in as to support MLO or to take better gain of MLO, or will continue with the same WMM-based scheduling?
Even Sudarshan can participate, I mean, because you also do the scheduling. Yeah, one of you, yeah, start. Rajesh, you can start. Yeah.
So QoS improvements in R2 are still stuck with a single link kind of scheduling, and that's what they are trying to optimize. But whatever he's talking about is something that needs to be improved upon on the higher layers. You cannot solve this problem from the Wi-Fi alone perspective. We in fact have two layers of scheduling now. One is to say, what do I do once I receive the frame here and how many can I handle? Do I want to split this single block equivalent content across 3 links? It's not worth it putting one frame on 2G and waiting for it to get transmitted. It may never go out and it may starve the 6G guys out. So these kind of decisions are done in one low layer of the scheduler. But the other more complex one, which is the what I'd say the secret sauce that anybody can think of adding, is in the higher layers. And that should be much more aware of the number of clients that you got, kind of capacity they have, the current statistics of the channel to the extent possible. You may not have the instantaneous numbers. But the more aware it is about the number of MLO clients versus legacy clients, etc., and their capacities and capabilities, I think there is a very good scope for improvement there in the schedulers.
Sudarshan, you want to add? And maybe Rama, Nadeem can pass.
I have a question for both.
Even you can, Sudarshan is also from chip industry, so you can make it.
It's a personal question. So I understand the scheduling aspect as you have explained, and yeah, we were actually debating it the other day. So I would like to know if this is this more complex than the OFDMA scheduling? I mean, just to say, I mean, is this that are we going to take so much more time to stabilize this, or is it going to happen easier than the OFDMA part?
So, quick, I think I will reinterpret this question. Is it going to be same fiasco as before, or are you going to solve it in before 2030?
I think it's definitely more challenging.
Okay.
So no hope.
But
Anyway, I think Rajesh, maybe both of you can also add. Do you think it is at the level, or do you think it's a more tractable problem that can get solved and address some benefits? Because you've both been positive, right? That it can address some real life benefits. So do you see that as a tangible thing?
Yeah, because as a hardware guy, we've already solved the problem.
Okay.
So, yeah, I think it's up to the software, scheduler to scheduling team to kind of build these robust, algorithms that use the hardware, well. And so that's why I think I would defer that too.
Rajesh, maybe he's
I
deferred
have a
it.
question in return. Is the MU problem solved?
Sorry?
Is the MU-related scheduling issue solved?
No.
So
I don't expect any better here.
So, Rajesh, the quick question, assuming that it's more of a software-centric problem.
It is definitely a software-centric
but
one,
do you
or
see-
rather an algorithm-based question. So you can work around several of these issues, but the kind of knowledge that the higher layer needs to have about the instantaneous needs of a channel is much more complex when you have a mix of 20 megahertz link, 2G is just 20, not even 40.
Yes.
2G is 20 in the field. So 20 megahertz link and a 320 megahertz link. Do you even bother using a 20 megahertz link at the same time? Probably never. 5G and 6G, yes, probably are going to use, but then 5G has got a lot more interference. So the knowledge of the channel and knowledge of each link that you're transmitting to, each client that you're transmitting to, has to be at the scheduler on top.
So do you as chipset players provide such data to software or higher layer people to write algorithms? Do you think that is within the scope of chipset players?
Oh yes, definitely. So there is a lot of diagnostic data that, so that is actually part of Wi-Fi 7, something new that there has been software requested for a whole lot of channel diagnostics and user statistics, right? So I think that is definitely part of the game, yeah.
Okay.
To
So I
help
think,
software make better decisions.
Open up the floor for
One
questions.
question.
I think there are a couple of hands, so please get
here,
the mic.
Here.
Whoever has the mic, ask please. Yeah.
Yeah, so this is probably a question for Rajesh, who here. So, I mean, just like how you mentioned about the MLO complexity, right? So even for EMLSR, right, when there is a switching happening between a 1x1 to a 2x2 for that short period of time in a burst, so that also adds a lot of complexity in terms of maintaining rate adaptation requirements when we are doing a TX, and also for the AP, it becomes very challenging. Any thought on that? Like, is that a reason why? And I'm from QA, and it gets really tough for me when people ask, is it working? Right?
First point is you're disclosing a secret about a specific chip. The switching between 1x1 to 2x2 is not an essential thing.
Okay.
It could be a 2x2 link sitting on 5G, that itself is switching bands instead.
Okay.
So you need not actually have that in your implementation. But if you do have an implementation which switches between 1+1 to 2x2 mode sometime, then yes, you shall have to maintain two different rate adaptation tables, you shall have to maintain multiple algorithms, the running numbers and etc. So that does add a level of complexity there. But I think that's the tangible one. That's something you can approach to optimize.
Okay, thank you.
Any thoughts? Questions, I think, please, whoever has the mic, you can ask Sheila.
Yeah. I have, like, 11AX actually had this HECQI report field wherein the channel, instantaneous channel conditions could be fed back. Whether it was practically used, that is a debatable question.
I can answer that, it's not used. Yeah.
So like that, again, is there any provision made by the standard in Wi-Fi 7?
Standard has tons of provisions. I mean, just sorry, I'm cutting into your area, because they might have actually built it. But knowing the usage, it's probably not used right now. So you don't have to bother with that.
Okay.
Quick, whoever has the mic, Ellen?
Yeah, so my question is, we've been talking about complexities and, the DLMU not working, OFDMA not working. I am primarily a 3GPP guy. Have you ever consulted the 3GPP folks and find out like where the discrepancies are coming out?
Well, I think Nadeem might be the right person having a foot. He's saying OFDMA and Wi-Fi is not working. Have you consulted with 3GPP folks? Anyway, Qualcomm has a big hand in 3GPP also.
It's working marvelously well in both the technologies, right?
I think, Nadeem, maybe you should answer, probably.
I think the big difference between 3GPP systems and Wi-Fi is the feedback channel, right? If you look at the 3GPP technologies, they heavily depend on client feeding back, rank, CSI, PMI, everything. And that's what makes the OFDMA work in that case, because you have very good timely knowledge of the channel. In this case, because the clients are not implementing the feedback scheme what Sheila was talking about, then AP is essentially blind, doing some open loop, decisions on how to schedule the clients in a multi-user scenario. So that's really, I see the big difference between 3GPP and Wi-Fi.
So I would add also to that, I personally maybe have a slight difference that it's not the feedback, because I don't think Wi-Fi feedback really helps considering. I think it's the fact that one is a pure scheduled system and OFDMA fits that framework. Here you are trying to force fit that technology into basically an unscheduled system. I think that's a fundamental problem. I think we are running short of time, so I might have to cut short. So last thoughts from panelists on this. Anything that you want to add? I've been a little bit provocative, so please add. Rama, maybe you can start.
Yeah, it's probably more of summarizing. I think we are moving in the right direction, but a little slow. We can probably help the market by maturing some of these things before we actually go to the next technology.
So you think we are on the right path?
Yes.
Summary.
Yes.
Prasanna?
Yeah, I don't think we are lacking innovation. We clearly are innovating a lot. I guess.
But the innovations are not working.
Yeah,
Yeah.
that is right. So it's not lack of innovation. So, yeah, I think the point is maybe some more cadence, right, between standards and probably allowing markets to settle down. Maybe that's the way to go.
So to kind of disjoint
yes.
committees or whatever.
Yes.
I think the approach that Wi-Fi Alliance takes, looking at release 1, release 2, release 3, with the same base, that kind of approach probably will help us adapt to these new technologies better, gain better advantage out of it, rather than churning out every 2 years some new spec, which we don't know whether it will benefit or not.
I don't think we are lacking in innovation, but maybe we need kind of more direction. Maybe let's say we could take help of AI, ML to see how we can.
So AML will solve MLO problems.
To maybe plan better. Like let's say if we have AML to get the RF topology, then we could use that to kind of see which scenarios or which clients MU-MIMO could work better. And likewise for preamble puncturing. Maybe with ML we could know like at what times channels or which channels are causing interference and use it to come up with a better static plan.
So does your company on the back work on these things to make it work?
Not right now.
Not right now, okay. Rajesh?
I'm not sure about the AML aspect.
So you're not using AML, okay.
Thank you.
Okay.
Happy to admit.
Yeah.
But then the innovation aspect, there is quite a lot of innovation, and that's probably one of the Achilles heel that Jatin is unhappy about in the first place. So
I'm also not happy. I said it's not addressing the issues.
Exactly.
Yes.
So I agree with him. There should be more time for maturity of the existing features. But at the same time, I agree that the features that are getting developed today or that got developed before 4 years are now much more mature now, irrespective of whether it was added by Wi-Fi 7 or not. For example, Wi-Fi 6E is much more useful along with Wi-Fi 7 today. You cannot just like that discard away Wi-Fi 6E as a useless technology because you just brought in 6 gigahertz to us. It has become much more relevant now. As the standards grow, that's how things are going to adopt. And from unknown places, you might get benefits, like EMLSR. Nobody expected that EMLSR would bring power save benefits for a single link EMLSR. That's one of the features that some mobile makers are asking for, single link EMLSR. It might sound like a useless thing. It's where you say that I am an EMLSR client, but I got only one link. I'm never going to switch between links. But as an AP, start using MERTS with me. You might ask, what's the advantage of using MERTS here instead of a regular RTS? The MERTS gives the client a lot more time to switch from a low power 20 megahertz 1x1 mode to 320 megahertz 4x4 or whatever mode it supports. So even when it is active, the client could be saving quite a bit more power than in a regular use case. So advantages do come out in unknown avenues from the development that happens today.
Okay, thank you. So give us a big hand for the panelists. So summaries, buy your Wi-Fi 7 router in 2030. That would be the summary? Okay, thank you. Thanks once again. Yeah.